So we're in the last lecture video for Module 3. Now in here we're going to talk about math functions, but before we talk about them, there's something that I want to talk about just for a little bit, and that has to do with the rules to numeric storage. So your computer is likely either 32-bit or 64-bit. And what determines that is the platform that you're dealing with. And Python version 2 could run 32-bit or 64-bit, and if it ran 32-bit, there's a range of values that it could have, and it's just over 2 billion plus or minus. If we're dealing with a 64-bit system, then we're dealing with something that goes way beyond that size. But with that said, if I try to store a number greater than 2,200,000,000 whatever, or 2,147,000,000, it's going to have a problem as an integer in that 32-bit system. 64-bit, non-issue. The numbers can be so much larger. We had a data type back in Python version 2.x. It was called a long. We don't have it anymore in Python 3. So in Python 3, it's just an integer. In Python 2, we had what boiled down to little integers and big integers, depending on how much space you wanted to reserve for it. And we don't deal with that in the version of Python we're going to use in this class, and there's actually no reason to use a legacy version of Python that I can find rational. It just doesn't make sense to me to use an older version, except to understand how things were written in the past. I'm going to talk a little bit about floats, and we've hit on it to a degree. They're much like integers, with the exception, and we treat them much like integers. The exception is that they have a decimal point in them, or associated with them. Everything else that we've dealt with up to now is the same integers and floats, with the exception that one has a fractional or a decimal point and things to the right of it, and the other does not. Now, the number 5 as an integer is just a 5. The number 5 as a float is 5.0. So when we represent what's being stored there, it represents something to the right of the decimal point if it's a float, whether there's a value other than 0 or not. Now, one of the things that we'll talk about in the future when we're dealing with strings is precision point, and how far out to the right do we want to go? And does it matter? It does matter. Because when you do math in Python, or you do math on paper, and it's using a floating decimal point or a fractional number, how far out you go will impact the results. And it's a big deal. And we'll see it as we move forward and out as we're performing mathematical calculations, how things can vary depending on how we truncate those numbers or set the precision point. That's something we'll talk about here in a little bit. So, like I said, here we're typecasting or converting it to a floating decimal point. These are all things that you've seen in the past. We did it in the previous few videos. Okay. So, I've got math functions, and the math functions I want to talk about a number of different functions, and I'm just going to touch on them. I'm not going to dig deep into them. And let me drag the page. I've got the page here to your right next to the video. A link to it says math functions. And we've got a number of built-in math functions that, just think of them, like I said, as tools in the tool belt. At this point, it's like we just walked into Home Depot and we see a ton of tools out there for sale. Do we need all of them? Absolutely not. I don't want to invest in a tool that I'll never use. But if there's something I may use or I know that I will use frequently, that will yield more investment from me so that I'm more experienced in how to use it and it becomes easier to use. Or I don't even have to think about what I'm doing as I'm using it because it becomes second nature. The print function, it'll become second nature to you very quick. Input, same thing. So here's a list of different functions that are mathematical functions. Right? There's what we need to understand when it comes to these functions. Now, in Python, we've got things that we call libraries, and they are classes of code that have already been created by somebody else. And they could be built in, and they may not be built in. So there are things in programming that we may have to import. And depending on the programming language that we're dealing with, the syntax of how we go about that may be different. We could use the word import. We could use the word include. So depending on the language, we are doing about the same thing. We're just saying it a little bit different. So in this example, you see, here's a comment, square root calculation. Import math. So there is a library of math functions that I want to have the ability to use or reference as needed. And if I, at the beginning of all my code, I import math, that then gives me access to all of the math functions in that math library. So with that said, that import math statement should make sense to you now, knowing that, well, that's just a library. And by me saying import math, that gives my program access to all the functionality or all the functions built into that library. Now, in that library, here's a list of all the functions that are in math. What's the square root of something? It's the power, the arc cosine, so many things that you may deal with in trigonometry and calculus. There's a function built to do that for us. I don't need to pull out my calculator and do the calculation. Okay? So just know that functionality's there, and now you know what that import statement means. That there's a class of code somewhere that we're importing, or library we're importing, that has many resources associated with it that we can use. So we're importing math so we can do something. The word pi, Pi, is in the math function. it's reserved in the math function. And if I reference it after I've imported math, it will have that number, so I don't have to type that out. I just reference pi. Okay? So with that said, I will see you in the next module. Take time to go through and complete the quizzes. We've got 3 quizzes. It's quiz 6, 7, and 8, if you haven't done so already. And always complete the reflection and let me know what works, what doesn't work, what can I add to these. And I appreciate you being here. Let's keep on going.